Take a look at the AU. There are 3 connectors on it. The small 50-pin connector in the top left is the power/control header. It has signals for power, programming, and other special control signals. The top 80-pin connector is bank A, and the bottom 80-pin connector is bank B. These are where most of your signals are routed through. Looking down the side of a header, the pinout takes the format of ground, pin, pin, ground, pin, pin, ground, pin, pin, ground. This is done for signal integrity. The name of each pin is the bank letter followed by the pin number. For example, the first I/O pin on bank A is A3. What would have been pins A1 and A2 are actually grounds. If we wanted to route our serial signal to the pins on the connectors instead of the internal serial interface, we would just change the pin names from USB RX and USB TX to something like A21 and A23. Since these are just basic signals, we can route them to any I/O pins on our board. The BT is a little unique in that it has banks A and B on both the top and bottom, but they're fully independent. To specify which side you're connecting things to, you use the side attribute. Looking back at our basic constraints file, we can see the side attribute is set to top for all of the pins. The syntax with the attributes surrounding the pin declarations is just shorthand for putting it on every single line inside the block. We could have written the pin declarations standalone like this. Because the top and bottom of the PT are fairly similar, this makes it possible to select which side you're attaching a board to simply by switching one value. For example, if we had a project using an FT+, if we wanted to attach it to the bottom instead of the top, we can open up its constraint file and change top to bottom. If you found this video helpful, don't forget to like, comment, and subscribe to see more videos like this in the future. As always, thanks for watching.